the vibe coding problem, and the hidden cost of unconstrained AI. Now, vibe coding feels amazing at first. You punch in a prompt and boom, suddenly you have a website. But here's the catch. It's only fast until your AI suddenly decides to invent an entirely new web framework from scratch. Or maybe it uses completely incompatible libraries that just paint you into a corner. Those are what we call architectural one-way doors. On the flip side, we have spec-driven development. This approach is totally deterministic. You're the one setting the guardrails, and everything is strictly version-controlled, which keeps you firmly in the driver's seat, where you belong. There's a great concept that really sums this up. If you drop an AI into a complex code base without giving it any state or constraints, it doesn't just guess, it actually assumes it knows best. Because the AI doesn't have a human sense of taste or understand your specific conventions, it's absolutely going to make its own architectural choices. And the result? Usually a pretty messy web of unscalable decisions. That brings us to Section 2, Spec-Driven Development Defined. Let's talk about formalizing your guardrails. So what is spec-driven development, or SDD? Think of it as writing the ultimate deterministic prompt framework. It's a practice that completely flips our modern AI workflow on its head. Instead of just immediately asking for code, SDD forces the AI to actually read your specific repository context, your coding style, and your constraints. You're front-loading all that deep architectural thinking before a single line of boilerplate is ever written. Basically, you decide the what and the how way before the AI is even allowed to touch the execution. Moving on to Section 3, the core artifacts, or building the state machine. SpecKit is really interesting because it operates as a strict state machine. You don't just jump straight to coding anymore. First, you start with a constitution. From there, you build a spec that outlines your features. After that comes a technical plan, followed by a detailed breakdown of tasks. And only at the very end of this strict sequence do you actually reach the implement phase. Let's break these down a bit. Let's start with the constitution. This file is the absolute baseline of your entire repo. Think of it like a strict set of rules you're handing to a brand new junior developer. It tells the AI exactly what the non-negotiable tech stack is. Must it always deploy to Azure? Does it have to be a static-first vanilla HTML site? Do you strictly follow the you aren't going to need it or YAGNI principle? The constitution basically locks all this vital context in place for every single future feature. Now, think of this next part as your cheat sheet for mapping out the remaining artifacts. First, the specification, or spec-MD, separates the what, meaning the functional requirements, from the how. The how actually lives in the technical plan, which is what dictates the data models and the exact technologies you'll use. And finally, the task list takes that technical plan and breaks it down into highly actionable, bite-sized steps that the AI can easily execute without getting lost or confused. All right, Section 4, clarify and analyze commands. Let's look at debugging the spec. This right here is where SpecKit truly shines. It includes this highly interactive clarify command. Before it writes any code at all, the AI will literally quiz you right there in the terminal with up to 5 multiple choice questions. So for example, it might say, hey, you asked for a podcast page, but what specific episode metadata should be displayed? Essential, extended, or custom? It literally forces you to fix your own blind spots before any generation even begins. It's incredibly smart. And right after you clarify, you analyze. Once you have all your markdown artifacts generated, you run the analyze command. The AI compiles everything and actively looks for logical discrepancies across your files. It's looking to spot severe violations. Like, imagine if your technical plan accidentally tries to import React when your constitution explicitly demands a vanilla HTML project. It catches that stuff. It guarantees total alignment right before you hit implement. Next up, Section 5. Implementing the code. This is all about the human in the loop. Because SpecKit generates pure standard markdown files, it entirely avoids those complex proprietary formats nobody likes. It just leans heavily into standard Git operations. And what this means for you is that you can branch out your features, let the AI run wild, and implement the task list on that specific branch. And if the model hallucinates or just makes a dumb mistake, you just do a standard Git revert. You retain 100% safety and version control the entire time. In this workflow, the whole paradigm shifts. You are no longer the code monkey writing every single line of boilerplate. Instead, you're stepping up as the systems architect. The AI executes the tedious tasks, and you, the human in the loop, review the implementation. You maintain absolute control over the repository state. The spec essentially becomes a living document that you update manually if needed, which ensures there's absolutely never any blind auto-merging to production. And finally, Section 6, Scaling AI Workflows, where we look at deploying Spec Kit. This thing already has over 53,000 stars on GitHub. It has absolutely exploded in popularity. And the reason for this massive adoption is actually pretty simple. It's an incredibly lightweight, open-source standard that just plays really nicely with the tools developers are already using. Setting it up is shockingly simple too. There are no heavy NPM packages polluting your node_modules. It's purely a collection of text-based prompts and helper scripts. You just use Python's UV package manager to run the lightweight specify CLI. This seamlessly injects the custom prompts directly into your IDE. So whether you prefer Copilot, Claude Code, or Cursor, it just works. The true power of the specify init command is definitely its versatility. You can absolutely bootstrap this into a fresh greenfield project to set things up perfectly from day one. But arguably, even more importantly, you can run it directly inside an existing 5-year-old legacy codebase to enforce strict new guardrails on all your future features. And as you start to scale, the possibilities get really incredible. Because your functional spec is completely detached from your technical stack, you can literally fork your markdown. Imagine this. You could have one AI sub-agent build a Next.js version of your site and spawn another agent to simultaneously build a Hugo version based on the exact same functional requirements. Then, using Git work trees, you just evaluate their performance side by side to find the absolute best architecture. It's a game changer. So I want to leave you with this final kind of provocative thought. If tools like SpecKit are automating the boilerplate, the days of just typing out mundane logic are definitely ending. But listen, this doesn't replace you. It elevates you. So the question is, how will you evolve your workflow to step up and become the ultimate systems architect your codebase desperately needs? Thank you so much for joining me for this explainer, and happy building.